So number 2 wants us to find the partial fraction decomposition of the rational function, and this is really the backwards direction of number 1. So we're kind of starting with the answer to number 1, and we want to work back to the question. So this process is pretty involved. These problems take a little bit of time, or a lot of time. So I want to essentially split this back up into the original 2 fractions that we used to add these. So I'm going to take 7x minus 1, x plus 2, x minus 3, and I know the original 2 fractions would have these as the denominators, but I don't know what the numerators would be, so I'm pretending we didn't do number 1. So I don't know what the numerators would be, so I'm going to call that A and B. So somehow I need to figure out what over x plus 2 plus what over x minus 3 would equal 7x minus 1. So my next step is going to be to multiply by the LCD, and I'm going to multiply the entire equation. So x plus 2, x minus 3. And I'm multiplying every term. So if you want to show it on both sides, you can. But what's going to happen is it's going to cross out here, 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 and here, and just leave 7x minus 1 is equal to, on the first fraction, the x plus 2 is going to cancel out with the x plus 2 and leave the x minus 3. So I have a times x minus 3. On the second fraction, the x minus 3 is going to cancel out, and you're left with the x plus 2. So plus b times x plus 2. Okay, so let's distribute the a and the b. Okay, so my next step is I want to group the x terms. So group the x terms, and I'm going to go to the next slide. So I'm just rearranging my terms. So 7x minus 1 is equal to ax plus bx minus 3a plus 2b. And the reason I'm doing this is so that I can factor out the x. So I have 7x minus 1 is equal to x and a plus b. I'm actually going to put the other terms in parentheses, and I'll show why. So we're going to do a process that's called equating coefficients. So equate coefficients. And it's not really a process that we've ever done before, so this is a new process, and really what we're going to do here is we're going to look at the similar terms on both sides of the equation. So on the left hand side we have 7x, or I have a 7 being multiplied by an x. On the right hand side I have an a plus b being multiplied by an x. So the x is getting multiplied by 7 on the left, and it's getting multiplied by a plus b on the right. Well, since this is an equation, that means the two sides need to be equal. So if I want to talk about x's, I know that a plus b has to be equal to 7. Let's look at constants. So I have a -1 on the left, and I have all of these, which don't have any x's. These would be considered the constants, and those are on the right. So of my constant, I have -3a plus 2b is equal to -1. Okay, so again, these are pretty big problems. This that I have right here is a system of two equations, two unknowns. So we can solve the system of equations either by the elimination method or the substitution method or by graphing. I'm actually going to use a matrix. So as a matrix, this would be 1, 1, 7, -3, 2, -1. And let me type this into my matrix. And then I want to do the RREF, so the reduced row echelon form. So over to Math under the Matrix menu. And if you do that, then you get this, which the advantage to putting it into reduced row echelon form is whatever your final column is, that is what your answers are. So that really means that A is equal to 3 and B is equal to 4. So my final step is I need to put these two back in the fractions because, again, our ultimate goal was to split up that original rational expression. So 3 over x plus 2 plus 4 over x minus 3. And that'll be our final answer, which again is consistent with number 1 because that was what our original problem was in number 1. So this, we reversed the process.